Eric,
Hey Charles,
how you doing, man?
I'm good. You know what? Remember that episode that we had? You know, where I was drinking the acid from the database.
Yes.
I really like it. Look at this. You know, look at the color. You know,
I can sort of see that color.
Yeah,
What do you have?
recall
What
the
do you?
color?
Yeah.
It's great. It's like a great drink now. Yeah. So
So you're
anyway,
drinking battery acid,
yes,
all right?
we're not talking about real acid today, but we are talking about things that have to do with acid in the database sense, namely immutable collections.
Aha.
And so I'm here with two of the folks behind that technology. So why don't you introduce yourself?
Yeah, my name is Immo Landwerth. I'm a program manager on the BCL team.
Yep.
I'm Andrew Arnott, a developer on the Visual Studio project and build team.
Cool. And Immo, just to say, is a longtime Niner who we basically brainwashed, and now he comes and works here. Yeah. I'm just kidding, man.
And then we kind of half share an accent, so that's kind of fun too.
But he's from a different Scandinavian country, if I recall.
Yeah, very different Scandinavian.
Yes.
German.
All right. So, immutable collections. What are immutable collections for? Imagine that I have to kind of explain to a first-year computer science student what is an immutable collection, because it sounds like a contradiction, right? Because a collection is something where I can put things in, and if it's immutable, is it like the empty collection always?
Yeah, I think you wrote a really good blog post on this, because I think to get started, when we designed the whole framework, most of the stuff that we built in 1.0 days was basically around mutable, right? So everything was mutable. You could basically add whatever you wanted to it would have side effects. And then we also had this thing called read-only collections, which is basically the idea is that at some point you want to either snapshot the thing and then no one else can add to it anymore, or you want to have things like dictionary where you have like two collections, keys and values, and you don't want people to add individually to them, but more as a side effect to act as a dictionary, you update keys and values. So basically these two things are read-only, so the user can't add to it, but the things might change, like because of side effects. And the original design of the BCL was more or less, it's mutable unless the interface tells you it is read-only, then you can't do it. And then you could use basically it becomes a policy whether something would never change or change on the title, as a side effect basically. And I think immutability will be fairly different to that.
Right. In fact, one thing I would clarify, though, is that read-only classes and interfaces in the .NET framework today are only facades around mutable collections. So in addition to the side effects of values that have members that change, just because you have a read-only list doesn't mean the list can't change because somebody has a reference to the mutable version, which is a potential false sense of security. Erik Lippert has a series of blog entries about immutability and the different kinds of immutability that you have. And then, yes, I have a couple of blog posts as well where we talk about that, and specifically collections and in general why we went the way we did. We had to define, okay, what does immutability mean in this framework, and how do we want to tackle that problem?
Okay, so let's talk, because I think you gave a great answer what is read-only and what is mutable, but you haven't explained yet what is immutable. So so let's
So immutable suggests the data will not change, will not ever change. In our implementation, we take it a step further and say it will never change, but freezability or frozen collections also mean the data never changes, at least once it's frozen. Okay. But it implies that if you were to change it, you'd have to copy the entire collection. These immutable collections both never change, yet they efficiently change, which sounds like a paradox, but we do it by allocating new memory for the differences between the original collection and the new collection. So if you have a reference to an immutable collection, it really will never change. But if you wanted a reference to a collection that was based on that, but with a few changes applied, you can do that, and it takes very little CPU and very little memory.
So let's kind of step back to kind of V1 and kind of try to if we can put this in a larger context. So one of the data types that has always been immutable were strings.
Yes.
And then when you want to kind of mutate a string, you use a string builder, and then at some point you kind of turn it into a string. Is this comparable to what you're saying with freezing and unfreezing, or
Yeah,
or is this completely kind of, am I completely on the wrong track?
No. I mean, this pretty I think WPF had some collections that were based on that idea, right? You would basically add stuff to it, and at some point you would say, I'm done.
Yep.
And then you would freeze it. But I think the interesting problem there is, it basically is based on the ideas that you do work only up front, and then at some point you are done forever.
Okay.
So
Yep.
if you have a system that isn't built on this promise, where things change over time, let's say an IDE, for example, where whenever you do a keystroke in the IDE, there is a representation for the actual document, and you want to capture the current state of the system, and you want to snapshot it, give it away to a background thread to do something like IntelliSense, code colorization, or whatever. And now the problem becomes, if you can't do this, and if that would mean you have to copy all the time, then this fundamental assumption is no longer true, and then you have to do something else. And for this, we didn't have anything in the framework.
Okay, so the real trick is that the structure itself is kind of incremented, or is grown incrementally.
Yeah.
So you can still add things to a list, but if I hold a copy to the old list, I won't see any of the changes.
Correct.
Now, that sounds very much like what people call persistent data structures in the functional programming world. Is this the same thing, or?
I'm not aware of what the definition of persistent data structures in that context is.
But like in Clojure, for example, the Clojure programming language, where they have a lot of these data structures, is this related to that?
I'm not intimately familiar with it either, but I have seen several people who have looked at these immutable collections call them persistent collections, so I think it's the same thing.
Okay.
We do have an interesting twist on it as well, though, just like the string and string builder
Yep.
that you mentioned. These immutable collections not only, so you can, if you have an immutable collection, you've got 1,000 items in it, and you want to add 5 more. You
Yep.
go, of course, add range, add 5 more, and we return you a new instance of that. And that new instance is immutable. But just like the string builder, if you're going to make lots of top-level calls into it to assemble a big long string, you want to use a string builder so you're not allocating so many objects. These immutable collections have builders along with them so that you can take an immutable collection, and you're going to make lots of changes to it as several individual calls to it. Create the builder first, which actually shares the underlying data structure, so you haven't allocated anything more than a small object for the builder. Then you can make as many top-level calls into it as you want. At that point, you don't have the thread safety because it is mutable. Just your builder is. The immutable collection that it came from is still safe. You make all the changes you want, then tell the builder, hey, I want the immutable reference back, and it'll then create a new one-object facade over it that is immutable, and you have all the thread safety guarantees as well. So it's just like the string builder. You can go from string to builder, then back to string, and you're all set.
Okay, so you can then make your mutations or your additions more chunky instead of kind of doing like many small.
Right. And you would do that to reduce GC pressure in critical scenarios. Otherwise, you don't need to deal with builders usually.
Yeah.
Okay, and now that I have 2 people here from the BCL, there's like my bike shedding question. I'm surprised that there's add and add range, and that there's no overload for add. That why do we need add range, and why can't we just have add with an innumerable of parameters?
Well, you could imagine having a collection, let's say list of t, where t is actually non-enumerable, right?
Yes.
Now the problem is if you have an add method that takes the t, and the add method that takes an enumerable, the code would be ambiguous. You would be not able to add to that collection at all. So basically that's why it's an overload with a different name, as opposed to just an overload with the same name.
Okay, and so now to go more about naming. These things are called immutable collections. But as you already said, they are kind of, you can kind of, mutate them. But the other thing is that, and you mentioned Erik Lippard's blog post, which I recommend to everybody, is that they are only immutable on the surface, right? So if I put in if I have an immutable list of arrays, then I can still mutate the arrays in the list. How harmful is that, or how confusing is that, or is this just the fact that we're living in an imperative world where there's always some mutation happening at a certain level?
It's definitely something to be aware of. You can't assume that you've got an immutable graph deep just because you're using an immutable collection, like you say. It can be mutable objects inside. In the scenarios that we've applied these immutable collections to in our products so far, we tend to put immutable data into the immutable collections. So the whole world is immutable, and it's a very nice way of solving the problem. and it allows us to do multi-threading without locks, and it's very, very nice. It's allowed us to improve the performance and responsiveness of Visual Studio in particular in a lot of good ways. As far as, say you've got a mutable type and you want to store it in an immutable collection and you'd like it to be immutable, there's still a lot of work that we can do in tooling or library support potentially in that area to help you, because right now writing an immutable object is a lot of work. Actually, my most recent blog post, more recently than the immutable collections, talks about that problem, and it compares a 4-line mutable class with 2 fields in it. It's very easy to read, very easy to write, maintain, and then it shows the immutable equivalent, and it's 200 lines long if you want to support lots of interesting scenarios. And we can improve that, so I have a T4 template on this blog post you can link to where it'll take any mutable type and generate the immutable graph for you, and it can be deeply. So if you've got this series of types all reference each other, you can turn that into a mutable thing at design time while you're writing your code, and then you have now immutable types with builders just like the collections, except now these are for objects, so now you have something you can put into an immutable collection that's totally immutable. Still more work to do in that area, but we're working toward helping in that area too.
Okay, and now another question I have is with regards to equality of immutable values. Well, I come from a Haskell world where everything is immutable and everything has value semantics. So if you say, a list with one element and another list with one element, they are indistinguishable because they are the same values. So maybe does it make sense with immutable collections that if I have a collection where I have added 1, that should that be different than another collection that contains only 1, or should they be the same?
I think that is partially philosophic, because it
kind
of depends on what system you're building. I think the problem in terms of how would you implement this is that you could easily imagine that the performance of this comparison might not be super efficient, right? Because we can't guarantee that if you have some collections that start at the same state, depending on how you get there, you could have different instances, and now we would have to do a deep comparison at all times, which might be relatively expensive. At the other hand, like if you think of where these things become valuable, like for example, if you looked at Roslyn, the next version of the compilers, their whole system is built around immutability. And so if you basically have a single keystroke in the IDE, you get a snapshot of the whole environment that basically contains that particular keystroke. Now, if you do comparisons, you are mostly interested in whether something changed or not, which basically means you can just use reference equality because if nothing changed, it's the same instance, as opposed to someone else constructed that thing on the side, ended up at the same state. So I think reference equality in many cases just gets you the thing that matters, I would say, but it's extremely cheap. Versus value comparison for the whole graph might be relatively expensive.
Yeah. But this, I brought this up because it is a philosophical argument. Because if you look at, we're talking about immutable lists, but we're still relying on something that's very mutable, namely object allocation. Right? The fact that if I I create a list of one element and I create another list of one element, that I can see that they're different because I can observe the side effect of allocating the memory for the list. So it's kind of interesting that there's this hybrid world where certain things you want to be immutable and more like functional style, where other things we really rely on the fact that under the covers mutation is going on, and there's like a different address is given to each of these values.
Well, we should call out too that at least in the preview of the immutable collections that we've released so far, the equals methods on these collections actually has been overridden, and they do have content equivalent semantics like you described.
Okay.
Now, I don't know if we'll keep that when we finally release because of the performance concerns and the fact that this is a deviation from a pattern that .NET Framework has set already. Usually we don't overload equals, it's just reference equality. It might be interesting to get some feedback from the Niners.
Yes, and I can tell you in Haskell there's a kind of whole sport of observable references, where people want to observable sharing, where you want to build something, but you want to kind of know whether there's something that's shared. Another interesting question is, how do you build cyclic structures?
So and the immutable theorists will tell you this right away. You can't do it in a purely immutable world. Obviously, collections don't directly reference other collections. You might have so I'm not sure that applies. I haven't run into that question in.
Well, take Roslyn for example. In Roslyn, the syntax tree is immutable, but nodes know their parent, and nodes know their absolute position in the input. Now, the way Roslyn solved this is by basically saying there are two trees. There's the internal tree we don't give you. The internal tree is also immutable. The difference to the public one is that the internal one, nodes don't know their parents, and nodes only know their relative length. Now, the way you construct the immutable public version is they construct the root, give over the completely old tree, the internal tree, and then they construct themselves lazily. So technically they're like fully immutable and there are no side effects per se, but you have lazy initialization. So you still have to make sure that when you lazy initialize while reading from multiple threads from this, you have to make sure that once you constructed the subtree, no one else can observe a different instance. But I think that in general, like if you want to build this in a really good fashion, you either go like with the impure way where you build something like a dictionary and then you pass it in or whatever, or you have this relatively heavyweight thing that Roslyn has. But the nice thing in the Roslyn world is they don't do it just for immutability, they also have it for efficiency reasons, because if you do a keystroke in the IDE, you don't want to construct a completely new tree, right? You want to reuse like 99% of the previous version. But if every node knows their parent, the absolute position, that you can preserve that property very quickly. And I think it kind of depends on the problem domain you're trying to solve. I mean, if sharing is important, if having an easy way to construct it, you could just say the internal tree is the one that we give you, right? But then you would lose certain programming aspects. You cannot go to the parent. You cannot know the absolute position in the input, and that might be acceptable too. So the question is, do you need cyclic structures? You could maybe you can get away with not having it.
Yeah, but in Haskell, the standard example is the kind of infinite list of say ones or natural numbers. So you want to build a cyclic list that has one that's kind of on top of the list itself. And because Haskell is lazy evaluation, you can just write ones equals one cons ones. But in C#, where you have strict evaluation, you cannot write var ones equals because the ones is not yet defined. So often when you build cyclic lists, you start with null and then you do some assignments to kind of tie the knot. So that's but probably one way would be to kind of start with the mutable version, tie the knots and then kind of freeze it, and then you're good.
Right, and in fact, the immutable collections, in order to achieve the builder semantics for the to reduce GC pressure, we started when we were implementing them. They were truly immutable; all the fields were read-only. But actually, now under the covers, the individual nodes in that binary tree data structure that we use, they are mutable, but they have an immutability field flag that says I am now immutable, and we don't let anybody. If you wanted to mutate that at that point, now you have to allocate a new object. So that wasn't to achieve cyclical stuff, but it is kind of the freezability. Underneath these immutable collections, we're using freezability concepts to build data structure and get reduced GC pressure.
Okay, so another thing is like I think it's your blog post. You give a little table where there's the kind of the cost of inserting things, say in like a regular list and in an immutable list, or looking something up in a regular dictionary or in an immutable dictionary. Exactly here, this is the table I'm talking about, like right there. So the question there that comes to mind is what kind of tricks do you use to get these performance bounds?
So just about all the performance metrics are a complexity is O of log n.
Okay.
And that's the complexity wasn't that tricky. It was just using a binary tree and you get log n kind of by default. The tricky part was reducing the proportionality constant as much as possible so we can get as close to BCL mutable collection performance.
And I often say like log n is never greater than 64. So it's constant.
It's true. That's a good point.
For almost all practical purposes, it's blazingly fast.
Yes, yeah.
We did have, and this is one of the reasons why in the preview we see that there are interfaces and there are concrete types. Well, why do you want an interface that people could implement the interface and actually provide mutability characteristics and violate the contract, right? So maybe we only want concrete types. Well, the reason we did the interfaces was because people like Roslyn, who have very, very high requirements for performance. They have enormous immutable data structures. They have to be able to do things in a very specific way. Whereas the immutable collections we've provided here are general purpose. They're fast for most scenarios. They should work for almost everybody. But in some corner cases, you might, for example, like Roslyn, have very specific requirements where they want to make different trade-offs. They can implement the same interface, so they have the same contract, can interop with your app, and yet internally they have a different, say, order complexity.
So now you have this list here, with certain types that you exposed. Now, one type that I always miss, there's a sorted dictionary, but I often want not a sorted dictionary that's sorted on the keys, but that's sorted on the values. And then I always have, you have to have two dictionaries, and so.
Interesting. I haven't hit that requirement before.
Okay, well, if you search online, this is the interesting thing. If you search for that, there's many people that ask for that, and so you don't get any answers, but you find a lot of people that need that. So I was hoping, I was like, great, immutable connection.
Yeah, so I mean, this is a general trade-off that we try to do in the BCL team. I mean, the problem is, especially with collections, and turns out if you ask 5 people what collection they want, you get 10 different answers, because for most people, collections have two sides. One of them is the exchange characteristic that I can use my collection and pass it around freely in the system, and the other thing is the utility character, where you do some very specific thing, and so you want to have a very specific collection that suits you in that particular context. Now the problem is that you cannot really differentiate on types you want to use as exchange versus types you want to use just for utility. Some people say interfaces are for that, but it turns out that not necessarily, because if you have to version the framework, exposing interfaces is problematic because you can never add to them. So it turns out that classes effectively get to this exchange character. So the more types we add, the less exchangeable things become, because by definition, if that means you have 15 types to choose from, well, someone picks this, the other one picks this, and then interoperability loses at some point. So what we try to do is we try to say, well, we build the core that we believe like 80% of the people will have to use. The remaining 20%, granted, you can always do it yourself, or you can use a third-party library that does it for you. And especially with collections, you find that there's so many collection libraries out there that you can use, but you can get interoperability out of them. But I would say even if you would put them in the BCL, you might not get the characteristics that you want, because everybody now uses a different.
Yeah, of course. But just to give you that is not a weird kind of collection that you want, or dictionary where that's sorted on the values. Say you want to build a histogram. The order of the keys doesn't matter at all, right? I want to have it sorted on the values.
Yeah.
So that's kind of, I think, a very common case. Now, you mentioned something interesting about interfaces, because I love interfaces. I mean, I completely love interfaces. I don't like concrete classes. But as you say, for certain reasons, interfaces might not be suitable. Now, one of the things that I've been wanting for a lot of years is intersection types, and in that case that would solve the problem, because you don't have to you can say I expect the parameter to have this interface and that interface without having to define a nominal interface. So in that case your problem would have been solved, because you just compose your interfaces out of little interfaces.
And as far as I remember, we had over the years there were several discussions about enabling trades or mix-ins or whatever, but there was never really enough pressure, I would say, to actually do the feature. And whenever you talk to the language guys, you realize that defining a feature is always easy. The problem is, how does this feature interrelate with all the other 500,000 features that they're having? So typically the approach is a feature that starts with minus 1,000 points, and you have to verify your way up to say, well, this is really valuable. So if you look in the .NET Framework, for example, the really successful interfaces, I would say, that we really like are the ones that have one member and rarely change. So like Immutable, well, that's done, and iComparable, that's done. Now, the more you get into the, I would say, application world where your interfaces represents, you know, a concrete thing, things get more fragile. But I would say that on the application side, you rarely have this problem because it's your own code. So when you add a member, something breaks, well, you just fix it. It's only problematic for things that are in the framework. And over the years, like abstract classes get us almost where we want. The only problem with that is you don't get multiple inheritance. But even that, there are not enough like good examples in the framework where you would say, well, if you would have this feature, we could solve these 500,000 things more easily. There are always examples, but they tend to be too targeted to be really like, I would say, like worth it, more or less.
So now let me ask you a design question. So because you mentioned interfaces that have one method.
Yep.
My question is, why would you have those at all? Why don't you just pass a delegate in that case?
Yeah, that's a good point.
Because the other thing, like, is another, like, I love F# because of this, because F# has object expressions where you can create an anonymous instance of an interface, and in C# and VB you don't have that. So often you find yourself, when you have an interface with one method, you have a delegate that is the thing that you want, but
I think that like this is like, I think in terms of generics and constraints it gets a little bit more interesting, right? You can have code that says, I need something that is comparable and equatable. Sure, you could write the method to take in delegates, but now everybody has to construct those delegates with some meaning, and hopefully you agree on the meaning, right? If the type already implements that the meaning is fixed, you can just pass it in and then, you know, things just work. And I think that is more or less the primary motivation. Like there are several things like predicate, for example, we could have made an I predicate that you have to implement, but that would be kind of silly. So I think that, you know, Java, for example, doesn't have delegates at all. They only have interfaces, and it works pretty well.
Java 8 will have delegates, and they actually, I must say, I'm a little bit jealous on their method references. So it's quite, I think, yeah. Anyway, so Charles, you said there were some questions from Niners.
Yes.
Because we want to I want to get back on track to talk about immutable collections.
Of course, but let's. I mean, great. It's right in front of you. So scroll down to Funk of T's question. It's a historical question, and you can read it verbatim. I mean, basically, what he's asking is, why now?
Why now?
Why have you done this now?
Okay, I'm now reading Charles' private email.
No, don't read that.
At what point did someone finally say this is important and why? So I think what he's trying to say is like, this used to be an esoteric concept, you know, something that, you know, functional programmers talked about, but real programmers, you know, wrote mutable stuff. Why is this suddenly kind of important? And I think that's a very interesting question.
Yep. It is. I think you can probably talk more about the actual benefits that it you know, brought to VS, but like from my DCL perspective, typically what we do is, as I said before, like we start at the -1,000 points, so only when things become really available we add them. And I think that if you look back, I think 5 or 6 years ago, we always had the capability in the framework to write multi-threaded code, but it was like you even had to create your own threads, or you know, once you had it, you know, how do you chain stuff together? It was harder. Now I think the TPL, the task parallel library, the async keywords, they all made it like more mainstream. So now more and more people write code where things run in parallel. Once you have that world, I think there's more pressure on like taming the side effects. And I mean, Roston is a good example, right? Compilers typically pulled all the tricks in the world just to make things more efficient. The problem with that is, if you only build a compiler, that's fine, but whenever you build more complicated stuff on top of it, like an IDE, you have like 5 million entry points into your code that could all run in parallel. And now the only thing that is actually capable of reasoning about your system is if you just say, well, this whole subtree, if I get a handle on this object, I know that will never change. They tried all the other variations with locking stuff, you know, having flags that would indicate which things are valid, which things aren't. But it turns out that it is really fragile, and if you have VS where like, you know, 1,000 people party on the code base, or you even have third parties that are extending VS, it gets more and more harder. And I think once more people build things, we have an interest of having like core types that you can agree on, like how does the, you know, an immutable version of a collection look like. And that's why we added it now, I think, not like 10 years ago.
But so are you? is your argument that immutable collections give you some kind of isolation, like the I in ACID, and therefore you can have, it's easier to write multi-threaded code?
I think in general, like if you want to have something that is immutable, that is just an object, the language already always gave you the capability to do that, right? You only declare read-only fields, or you only have read-only properties. That's fine. But as soon as you have a collection type, because of the problem that you want to, incrementally change, now that becomes rocket science. How do you implement a collection that, does a lot of sharing and still provides a guarantee?
So that's why, I wasn't kind of half joking when I asked you in the beginning about the name immutable collections, because I do believe that, the name immutable collection is not really kind of, what these collections are about, right? Because they are not immutable. The whole point is that you can mutate them, you can extend them, but you do that in an efficient way.
Yeah.
Whereas if you would have truly immutable collections, then there would be no kind of smarts in there. They would just be values.
Yep.
And so maybe well, I don't know how far we can go by kind of fixing the name, but I do believe that it might give people the wrong impression that they're kind of totally immutable. But the trick is that I think the value of them is that you can incrementally update them.
Right.
Yeah.
Well, they do have the immutable guarantee. Not to miscommunicate. If you have an immutable collection, it will never change. So it's definitely immutable. It just happens to have an efficient characteristic for mutation if you also want to do that, but without violating the immutable contract.
Yeah.
From a VS perspective, the reason we originally wrote, it was a separate decision to actually incorporate these into the base class library and ship them on NuGet. But when they were originally developed as part of a Visual Studio feature to improve responsiveness.
So sorry, I missed the click thing, Charles. I want to get where's your
That's not a Surface, man.
Oh, okay.
That's a different computer.
Okay. Look at this. More mail. So this is not immutable. Look. You can see Charles'
side effects. Not my personal mail.
Yes.
Oh, it's not. It's just work mail.
Yeah.
So continue.
Yes.
We in Visual Studio, of course, performance has been hit really hard in Dev 10 as customers were saying Visual Studio just feels really slow, sluggish, solution open is slow, startup time is slow. In Dev 11 we did a lot to improve that, and one of the ways that we did that was we started looking at concurrency and asynchrony using all the new keywords before we actually shipped them, and we needed the features that these immutable collections would provide. So we wrote them for ourselves, and we said, hey, these are generally applicable. They're interesting to customers with all these keywords, as Immo mentioned. Mm-hmm. And so I think it's great that it's being incorporated in the base class library, and so that we're not building it as an internal tool and keeping it to ourselves inside Visual Studio. But why now? Because we had the same problems that we expect customers are having now, either with asynchrony or just the workloads that people are running on servers or in heavy apps like Visual Studio. That's so much easier.
It's a general thing with Moore's law, right? You can no longer buy a bigger computer. You buy a computer that has more cores. So unless your program becomes more parallel, it doesn't really help you. You can write more instances of your program, but running more instances of VS is not necessarily helping with the performance. So I think that's the general trend you can see, and I think we try to be earlier than before, because the problem with the BCL as we originally evolved it, you put it in the box, but then it's fixed and it's frozen. You can never touch it again, right? With things that we ship on NuGet, we get the benefit that we can actually get it out earlier, ask for feedback, and then react to it. Like the betas of Visual Studio and the .NET Framework in particular, typically after the beta ship, people could actually look at it. The time window to actually do any meaningful changes was so small that 95% of people was always, well, unless you report a critical bug, we will not going to fix it. So since you brought up naming, if someone will find a critical thing somewhere, we will probably fix it. Yes, it will break people, but it's a preview, right? And so that's the general idea that we have with other things as well. And NuGet just gives us a really easy way to try
So there's two interesting things that I want to point at. You mentioned, this is useful for us, so maybe it's useful for customers. I love that, because that is the thing, that's my rule in my team. If it's useful for us, it's useful for customers, because I also want my customers to build the same thing that I built. So that's a great rule. The other thing that you mentioned is also interesting, because if it's not on NuGet, it doesn't exist for me. Okay, the only way I ever kind of add stuff to Visual Studio is via NuGet. So do you think that this will radically change the way we might kind of deal with frameworks and so on? Because it gives you so much more agility, and you can always kind of have the latest version, and it's way simpler than installing, even like installing from an MSI where you have to go click, 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 click. You just right click. I love it. I mean, I don't know. This is like such a brilliant. NuGet is.
So I think in general, like the answer is yes. We also love NuGet. If you think of .NET 4.5, there were two things that we didn't ship in the framework, in the Redis. We actually shipped via NuGet. One of them was Dataflow, which is the TestFlow library extension that makes creating graphs of things that flow easier. And the second thing is our new version of the Managed Accessibility Framework, or MAF for short. And the reason we put both on NuGet is, first of all, we felt that MAF in particular wasn't really ready to put it in the framework because we weren't 100% happy with how it was. But at the same time, we also try to live the agile mentality, which is if you don't think you're happy with the result, that's a great time to ask for feedback. So you put it out, get it into customer's hand to actually play around with it. Now the problem with the framework is we have so many things that depend on that, we cannot arbitrarily change the framework. Like Visual Studio depends on it, other products depend on it. But if we put something targeted on NuGet, we can actually get feedback. We can evolve this independently, and that also means we have always like times in the schedule where we can actually change stuff. But the problem is that means you have to ship it in the framework. Yes, you can do the change, but no one will see that change, right? So like we have an enormously large backlog of little things that customer want us to do, like different parsing on enums, an extension method here, a method there. But because all these things are in this big framework, we don't have the time to actually do that. And like when we actually do have the time of working on the framework, then it turns out that we have a gazillion like really important business things we need to do first. And so these things always fall over, and we never get the chance of doing them. And if you look at what ASP.NET did, I mean, they pretty much live on Coplex right now. So they're even completely open source. If you want to get the latest check-in from yesterday, you can do that. But they also ship their binaries on NuGet, and that means they have a very, very, very tight feedback loop. You can ask for a feature, and you can actually like see the feature without growing like old, right? like when I joined the team, I still had like 5 or 6 things open on Connect that I filed like 10 years ago, and I think they're still open because the reality of schedules and big products is that it's really hard to do tiny things.
Yeah. So, but that begs the question: is like what is a framework, or what is the framework, and what kind of do you ship kind of separately on NuGet or not? Is there any kind of do you guys think about that at all?
Like my team now is like called the .NET ecosystem team. Like the BCL is like turns out almost all the work that I did in the last 2 years since I'm here is not necessarily BCL. The BCL is the smallest part of it. There's like more of the cross-cutting things we do, like whether it's API reviews across the framework, whether it's building stuff for NuGet. There's so many things we try to do now. It's too early to change anything concretely, but I think it's fair to say this. Yes, we're thinking about exactly what you just said, like what is a framework in general, and how do we want to evolve that in moving forward? Because the platform is 10 years old, and there's certain things in there that makes it harder to evolve stuff moving forward, but there's so many other things we really want to do, but it turns out we can never fit it in. So, yeah.
So now another question is like there's this kind of fixed set of types that you release now as immutable collections. Are there any other types that you are thinking about? And again, if there's something that you don't want to disclose, you just you don't have to answer. But one of the things that I often use is in a quite different way actually than people intend is I use JSON as kind of a better XML, not for serialization, but just when I need to work with trees. Mm-hmm. And like a lot of so it's really like a collection, but it's not like a linear collection. It's a tree, and we have system.xml, we have system.json or json.net. Are you guys thinking of having a more like tree-like structure that's immutable instead of only the kind of traditional? I can build it with the hash table, of course, but now I'm encoding this
So I can't answer from the BCL team, but if you guys watch my blog, I'm moving that direction because inside Visual Studio, along with these immutable collections, we built an immutable tree structure.
Yes, exactly. So there you see it. You know, you need it. So I need it too.
Right. It's not general purpose yet. We'd like to. I'd like to get it general purpose, and I'll publish progress on my blog. But the simple object graph post, which is atop my blog right now, starts to get us toward that end.
Yeah.
But I don't know if anyone wants to
So,
comment.
to be very fair, like the tree of T or tree node of T question comes, very often. And I think 4 or 5 years ago we actually had a design for it. The problem is that it is relatively hard to have a general purpose design because there's so many different ways to represent trees, and no matter what design you come up with, like we always felt like it was not really addressing 80%. It was like way lower than that. And I'm curious to see what your general purpose solution looks like and whether it's really general purpose or not. But I'm not opposed to this idea of having a tree. It's just that having a general purpose design is actually quite hard for trees. And you can make a decision like this is the one and only way to represent trees. But the other question is like, would someone actually use it? Like, would you actually exchange it in public APIs, for example, or would it just be a utility thing that you can use in like one of the 10 cases you need trees?
And I agree with you. The hardest part is often to make it like strongly typed because But that's why I like the kind of JSON approach because if you want a tree and you want to kind of pass it around, you usually don't want it to be strongly typed. So that works quite well, I think. Now another question I have is like a lot of people use the traditional collections for data binding and for two-way data binding.
Yep.
But now if your collection is immutable, how do you data bind your collection to a UI?
There's that, and there's also the C# collection initializer syntax that you lose as a result of using immutable collections because the compiler doesn't know how to generate code for it. So I don't know what the future directions are to solve those problems because data binding with these collections doesn't work either. You're right because they never change.
Yeah, I think data binding is, to me at least, an inherently like mutable problem, right? Because I mean, if you think of, let's say, a typical form where you would data bind to some model behind it, you have things like text boxes that text changes over time. So if you think of how mutable generally works, is that if you have a root object that holds onto like a bunch of stuff, you can never change the thing at the bottom, right? You always have to basically propagate it up somehow and say, well, you now have a new child that has this change in them. So you basically have to walk up the chain to understand like how to replace old values with new values and get the new object out of it. And I think this will be very hard to generalize in data binding, and chances are it's probably not even what you want. So what people do with data binding in general is they follow this MDVM pattern where you have a view model that is specifically designed to represent the mutable state of a particular view, although the view can be exchanged with other things. But generally, like at least the abstraction, like what kind of fields you expose and what the structure is encoded there. And the model behind generally is not what you would control. So this model could be immutable, but the view model that represents it would be mutable. And when you are done, you hit the save button, all the changes would be written back, and you would get the new immutable state out of it. And I think this is how I would see this being used in systems that are build our own immutability.
You can do one other thing too, actually, and I saw your Niner video of iObserver and iObservable. And in Visual Studio, where we applied the immutable collections, we do have eventing and conceptually a data binding application to these. We don't raise events in this typical text changed event sense, but we use the data flow, which just follows the iObservable pattern, to say, hey, we have a new value here, and we give you an immutable collection that contains all the new values, or an immutable object graph, and say, here's the new value, and they had the previous value, and they can diff between those very efficiently. So it's not data binding in the sense that WPF would automatically bind to it, but people who want to subscribe to data that is immutable data and yet you get notifications when it changes, you absolutely can apply the observable pattern to it and achieve a lot of the same goals.
Yeah, so I would say I completely agree with you, and I think instead of what you're saying is doing a batch approach, I think there's some really exciting possibilities where you get like unlimited undo, right? Because often you're working in a form, you're binding it, but imagine that the underlying model is immutable. Now you can always kind of easily go back to a previous version. So I do believe that, you know, I'm waiting for the first person that kind of writes a data binding library that really leverages the immutability. I think this would be really cool. So maybe Paul Betts, who worked on the kind of reactive UI, you know, can do something here. All right, I think we're.
Are there any questions?
Yes,
any more questions?
Any more questions? Let's pick one last question.
Okay.
Because I'm going to.
We should probably pick it from Exoteric because he's the one who started the thread.
Okay, so there's one question that's interesting because they wanted that as the first question, and then they promise you a free lunch. So let's do that as the last.
Yeah, but that was a joke.
no, because I'm going to now put it as the last question, and then you pay him lunch.
So while you're looking for, I want to throw in one more thing. A lot of people assume, well, I don't need immutable collections because I wrap it in a read-only collection and I'll only read from it so it's thread safe. And the MSDN documentation says, you know, instance members are not proven to be thread safe. And everyone assumes that reading, as long as all the threads are just reading, it is thread safe. Not true. There are cases in the BCL collections where a read operation, like a specific example is sorted set dot is subset of, sounds like a read-only operation. It is not thread safe. It actually mutates the underlying data structure. So if you want thread safety, you've got to use these. You can't use the BCL ones, at least unless you have proven otherwise.
Okay, so now I'm going to kind of stretch the time because this made me think of a question that I had, like, you know, in my queue, and then I'll kind of end with a user question. Often when you do a for each over a collection, you get this weird exception that the collection has been changed under your feet. Yep. Is this now gone with immutable collections?
Yes.
Oh, okay, good. Look, only for that, you know, they're all already worth their price. So
hold on. But I don't think for the
don't spoil it for me.
The builders, obviously,
Yeah, of course.
Because they don't have immutable guarantees.
Yes, yes. Okay, so now the last question. This is the question that will kind of get Charles lunch, but I'll interpret the question slightly different. So the thing is, like, it's a little bit of a pun. Immutable collections. Does this change everything? Now, I think what the Niner means is that what is the guidance when to use immutable collections, when to use you know, concurrent collections, because now we have like a lot of different collections in the BCL.
Yeah.
So do you have any guidance for the Niners when to use what kind of collections?
So in my experience, I think the adage is true, optimize for performance, last.
Okay.
Whether you use which kind of what mutable or immutable collections probably is not going to change your fundamental architecture. So it is a decision you can make later. If you're dealing with interface exchange types, again, your implementation can change without radically changing your application. So the answer, my answer is, it's usually a style choice. Where it really has mattered for us in Visual Studio is if you find yourself copying collections defensively a lot in order to make sure that you're dealing with immutable data or you're handing out a snapshot. That has over and over and over again in Visual Studio where you've seen that has ended up being a perf problem or because of GC pressure or just the CPU of copying the memory. Those scream use immutable collections. Now personally, once I lived with immutable collections a lot, I found I loved it so much that I even find myself working with immutable collections just as local variables inside of a method. Now, you could argue that's a waste, you could just use the immutable types, and that's true. Most of the time it doesn't matter, because most methods you write aren't going to be in a perf critical section of your app. So it's just a style choice. I haven't gotten my head around F# yet, but I do like the idea of functional programming, and these let you do that.
Yeah, so one of the, this is interesting that you say that, because often I use concurrent collections, even though I have no concurrency at all, but because the methods for adding, you know, you have like try add, and if it's not there, so you can kind of, you know, pack everything in one method call instead of kind of writing semicolons and do things in multiple steps. So it's kind of, you know, it's often a matter of style. I agree with you.
I think it also kind of depends what kind of things you are building. I mean, at the end of the day, if you're writing your own apps, I agree with what you just said. It's a style choice, and it's a choice like, what do you actually want to do? Like, what kind of thing you're building? But I think if you think of the bigger picture where you build a library that is reused by millions of people potentially, like JSON.NET, it kind of depends what the underlying design of that library is, right? If mutation is an important thing of your library, because that's how you designed the thing to be used, then well, you can use immutable collections and then update them, but then it becomes really artificial and it feels not like you're actually fulfilling the design premise that your system has. On the other hand, is if you design something like Rosslyn, where immutability is the big thing, yes, copying memory is not going to help you there, and it still feels like really artificial as well. So it depends on what you're building. I mean, if you're still living in the traditional world where you have object models that are mutable, then I would still go with the existing mutable collection. I wouldn't even use concurrent collections there because it still doesn't really fit that model. But if it's just your own method body, it doesn't really matter, then it becomes a style choice. But if you're supposed to build something that gets exchanged publicly, then there are additional constraints that you probably want to be aware of.
All right. Well, thank you so much, and I'm really looking forward to kind of more NuGet updates of this great library. And thank you so much, Charles.
Cheers. Thank you,
Yep.
guys.
Thanks.